Hi, this is Dr. Green. We're working on WebAssign Homework 8 and problem number 18. So here we have a statistics instructor, and they measure their student attitudes towards statistics at the beginning of the course, at the midterm, and then at the final exam. So we got three measures here. And then the attitudes were measured on a 16-point scale, and higher scores were more positive towards statistics. So we did this for 5 students, or I did this for 5 students in this example, so n equals 5. And these are the before scores, the midterm scores, and the final scores. And they ask us, based on the results in this table, we want to test whether or not the attitudes differed using the Friedmann Test. So this is a non-parametric version of repeated measures ANOVA, because we've got 3 measures and they're all on the same subject, repeated measures. And so here we noted that little n is equal to 5. We're going to need that a little bit later on. So the way that we perform this test, the steps are right here. What we do is we rank the scores across each row for each individual participant. Then we sum the ranks for each group. And then our test statistic is this formula here. So that's a given, chi-squared sub r, and then because it has a chi-squared distribution, and then we take that test statistic and see if it's larger than the critical chi-squared value, which is table B7, and we use k-1 as our degrees of freedom, where k is the number of measures. So in this case, k is equal to 3 because we got before, midterm, and final. So k is equal to 3. Okay. So, what I did was I took these and I found the ranks of these scores here. So I ranked everything by row. So if you look at student A, the 5 is the smallest score. So smallest is a 1. So that's the first rank. And then the 8 and then the 11. So that's a 2 and a 3. If you look at student B, then they ranked the final was their lowest rank, and then the midterm, and then the before score. So this is actually 1, 2, and 3. So these go backwards, 3, 2, 1. And then for student C, 4 was the smallest, then 7, then 9. So this will be rank 1, 2, 3. So 1, 2, 3. For student D, 4, 8, 15, those go in order, 1, 2, 3. And then for student E, the 7 was the smallest, that's rank 1, then the 8, then the 9, so that's a 2, 1, 3. So that's how I got the ranks. Then you sum down these rows, so the sum of all the before scores is 8, sum of all the midterm scores is 9, and the sum of all the final ranks is 13. So now we compute this test statistic down here. This is what we call the sum of the ranks. So they write that as sigma r. So our test statistic here, we do 12 over nkk plus 1. So it's going to be 12 over, our n is 5. So it's going to be 5 times 3, and then times 3 plus 1, which will be 4. And then that gets multiplied by the sum of the ranks squared for each one of these scores. So what that means is that you do the 8 squared plus the 9 squared plus the 13 squared. Okay, that's what this notation means here. And then you subtract minus 3 times our n, which is 5, and then times k plus 1, and k is 3 because there's 3 sets of measurements, so 3 plus 1 would be 4. And if you compute that on the calculator, you get 2.8. And then you compare that to the test statistic in the back of the book. So we want to compare that to, so this is our chi-squared sub r, and that's 2.8, and we want to compare that to chi-squared in the back of the book with, let's see, we're using k minus 1 degrees of freedom, so 2 degrees of freedom. And again, that is table B7 here. So if we go to table B7, so here is table B7, page 669. We are looking at the 0.5 level of significance and 2 degrees of freedom, 5.99 right there. That is our critical value. So if we come back here, this is 5.99, and we see that our test statistic 2.8 is less than 5.99, and we need it to be greater than in order to reject. So we are going to retain the null hypothesis. And then if you want to do this one in SPSS, it's pretty easy to do. You're going to enter one data column for each factor level, and then you're going to go to Analyze Non-Parametric Legacy Tests, K-related samples. You move your variables into the test variable box, click on Friedmann, and click OK. And so let's go ahead and do that real quick. And that actually gives this output table here, and you'll see your chi-squared test statistic is the 2.8. And then you see your significance of 0.247, which is greater than 0.05. And that tells you that you're going to retain the null and not reject. But let's see how to get this real quick. So here is our data. Before midterm and final, these are the values that we had over here for each student. And we don't have any other coding that we need to do. Don't need to, define any variables or anything. We just go to Analyze and Non-Parametric and Legacy Dialog, K-related sample. We bring these three variables over. If they're on the left-hand side, go ahead and move them over into the test variable box unless they're already there. And then make sure that the Friedmann is clicked and check OK. And so what you see here is our 2.8 chi-square and our asymptotic significance of 0.247. And if we go back, that's exactly what we have here. So there's that 2.8 and the 0.247. So this 2.8 and retain the null hypothesis. And that wraps